So we have seen the meanings of increasing and decreasing function. Now we will obtain the conditions to find the function is either increasing or decreasing. Means if the function is given, the interval is given and the question is asked, check whether the function is increasing or decreasing in this function. Then how to find it actually? So we will obtain that condition, how to find the function is either increasing or decreasing. To find that condition we will use the meaning of increasing and decreasing function. So first of all, let us find the condition for increasing function. Condition for increasing function. We know function is increasing when for the given interval y is equal to f of x in a to b is increasing such that x1 less than x2, then f of x1 is less than f of x2. This is the condition, this is the meaning of increasing function. Okay, now using this one we will find the condition to find given function is either increasing or decreasing. x1 x2 belonging to this interval a to b. So let x1 belonging to this interval a to b, we will consider those values. The first value directly x1, that is x, and second value is x plus h. Let x comma x plus h belongs to the open interval a to b. Clearly h is a positive, smallest positive number, so clearly x plus h is greater than x, such that h is greater than 0, smallest positive number, h is greater than 0, then of course x is less than x plus h. So here for x1 I will consider x and for x2 I will consider x plus h. Now x1 is replaced by x, x2 is replaced by x plus h. So here it will become, this one will become, therefore using this meaning f of x1 is replaced by x is less than f of x2 is replaced by x plus h. So f of x is less than f of x plus h, right? Therefore this can be written as this f of x, subtracting f of x on the both sides of this inequality. Subtracting f of x from the both sides of this inequality, what will happen? Subtracting f of x from this side, this will become 0, is strictly less than f of x plus h minus f of x. Okay, so is strictly less than f of x plus h minus f of x. This one, this can be written as this inequality. If I want to write it as a greater than or equal to, I will write this part first of all. So f of x plus h minus f of x is greater than 0. It is greater than 0. This one is greater than 0. 0 is less than this one. So this is there. Now I will divide by h on both sides. Divide by h on both sides since h is greater than 0, h is not equal to 0. So I can divide by h on both sides. Dividing by h on both sides, here divided by h on the right hand side of this inequality, 0 upon h will be 0 again, and this is there. We can divide by h because h is not equal to 0. H is not equal to 0. So I have divided on both sides. Now I will take the limit as h tends to 0. Remember, we have seen limit chapter, learned that limit chapter. So I will take the limit on both sides of this inequality as h tends to 0. But now remember, when I will take h tends to 0 means h approaches to 0, at that time what will happen? This term x plus h will approach to x directly. Means what? There will be f of x minus f of x. right? It will be 0. So at that time this inequality which is strictly greater than, here it is strictly greater than. Now when I am taking the limit, take limit as h tends to 0 on the both sides. So what will happen, look, limit as h tends to 0 of this one, f of x plus h minus f of x upon h is greater than or equal to, sign will be attached now for this one, because we are taking limit h tends to 0. So this is greater than or equal to 0. Now this becomes greater than or equal to 0. Now look at this part. What is this? What is this? Do you know the definition of derivative by first principle? Do you know the definition of derivative by first principle? Yes, this is nothing but f dash of x. This is nothing but f dash of x. Therefore, by definition of first principle for derivative, this is nothing but f dash of x, and this f dash of x is greater than or equal to 0. This is the condition for the function is to be increasing. Means what will you do? We will find the derivative of that function f dash of x if that derivative is greater than 0 for that required interval, then we will say that the function is increasing in that interval. Therefore, we will say that function is increasing in that interval. Means what is the conclusion? The conclusion is if f dash of x is greater than or equal to 0 in the given interval a to b, then y is equal to f of x is an increasing function, in that interval a to b. In that interval only, remember, we have seen in the previous video that interval is very important. So in this interval the function will be increasing if f dash of x is greater than or equal to 0. In the same way we can find the condition for decreasing function also. So what will happen for decreasing function? If you got this, I will go to the next part, decreasing function. So what will happen? Look at this. For decreasing function, x1 is less than x2. We know the definition. At that time what happens? F of x1 becomes greater than f of x2 for the decreasing function by our definition. In the previous lecture we have seen what is the meaning of decreasing function. So as your x1 is less than x2, at that time f of x1 is greater than f of x2. The inequality reverses here. In increasing function, here is less than and here is also it is less than in increasing. For decreasing function what happens? x1 is less than x2 but f of x1 is greater than f of x2, then our function is decreasing function. So this meaning we will consider here. Again I will consider these two values belonging to this interval. So for x1 I am taking x, for x2 I am taking x plus h. Now look at this, the same condition I will consider. X plus h belongs to this interval, h is greater than 0 and x is less than x plus h. Of course, h is greater than 0, therefore x will be less than x plus h. But now using this definition, what will happen? The inequality will reverse. This inequality will reverse. So f of x is greater than f of x plus h. Because of this, x1 is replaced by x, x2 is replaced by x plus h, and the process is same ahead. Therefore, what will I get here? F of x plus h minus f of x is less than 0. Look at this. This term is taken here and 0 is greater than this one. 0 is greater than this one, means this term is less than this one. Again the same process, divide by h on both sides. So what will happen after dividing by h on both sides? F of x plus h minus f of x divided by h is less than 0 divided by h will be again 0, and I can do this because my h is not equal to 0. I can divide by h because h is not equal to 0. So go ahead again, take limit as h tends to 0 on both sides. Again this will become, only this sign will change, this is less than, now this will become less than or equal to. This term will be less than or equal to, and again what is this? This is by definition of first principle is nothing but f dash of x, and hence your f dash of x is less than or equal to 0. This is the condition for a decreasing function. So conclusion, if f dash of x is less than or equal to 0 in a to b, in this interval a to b, then f of x is a decreasing function. F of x is nothing but a decreasing function. Got? F dash of x is less than or equal to 0, then f of x is a decreasing function. Okay, this is the condition for increasing and decreasing function. If f dash of x is greater than or equal to 0, then the function is increasing in that respective interval, and if f dash of x is less than or equal to 0, then the function is decreasing in that interval. Okay, these are the conditions. Now using these conditions for increasing and decreasing function, we will find whether the given function is increasing or decreasing in the given interval. Consider this example which is in front of you, that f of x is equal to 2 minus 3x plus 3x square minus x cube for x belonging to the set of real numbers. Can you see this? F of x is equal to 2 minus 3x plus 3x square minus x cube for this x belonging to the set of real numbers. Okay, so I will consider this function and I have to check if this function is increasing or decreasing in this interval. Complete your question. Find whether this function is increasing or decreasing. Find whether this function is increasing or decreasing in this interval. Okay, so consider this function f of x is equal to, what we have to do, what is the condition which we have obtained for increasing or decreasing function? We have to first of all find f dash of x. Remember the algorithm, every time you have to find derivative of that function with respect to x. So first of all I will find derivative of this function with respect to x. Differentiate with respect to x. So after differentiating with respect to x, this function will become f dash of x is equal to, look at this term, 2 is constant, so its derivative will be 0, minus 3x minus 3, it is coefficient, derivative of x is 1, plus 3 times derivative of x square, we know this derivative is equal to 2x, minus derivative of x cube is nothing but 3x square. Derivative of x cube is nothing but 3x square. This is the derivative f dash of x. So this is equal to, I will rewrite the terms, minus 3 plus 3 into 2, 6 times x minus 3x square. I can take this minus 3 as common, minus 3 common, into bracket remaining part. Now look at this, minus 3 is taken outside, I will write this quadratic polynomial, in the descending order of its index, of its power. Okay, so first of all the term will be x square, minus 3 is out, plus 6 is there, so here it is minus 2 times x, minus 3 into minus 2, that is plus 6, and last one minus 3 is outside, so plus 1 is there. Now look at this, this function is equal to minus 3 into can I factorize this bracket? Can I factorize this bracket? Yes, this is the square, this bracket is square of x minus 1, right? X minus 1 bracket square is there. Now look at this term. What I have to check? Whether this value is greater than 0 or it is less than 0. Whether this value is greater than 0 or this is less than 0. So this value will be greater than 0 if both the terms are positive. It will be less than 0 if one of them is negative. So look at this, minus 3 means negative term is there and x minus 1 bracket square is there. So it will be always positive. We know that square of every real number is always positive. Therefore, this term is positive. This one is negative. Positive into negative, product of two terms. One of them is positive, another one is negative. So this product will be strictly less than 0. This will be strictly negative. This product will be strictly negative. It will be 0 where if x is equal to 1. If x is equal to 1, it will become 0. It will become 0. So here, therefore, f dash of x, this value is less than or equal to 0. Why? Why less than or equal to 0? Because this term is negative, this term is positive. Product negative into positive will be negative. But it will be 0 also. Where it will be 0? If x is equal to 1. My x is belonging to this interval. X is belonging to R. So x will have the value 1 also. And if x is equal to 1, this bracket becomes 0. And 0 into this one will become 0. Therefore, this is not strictly less than. This is less than or equal to 0. Now look at this. As f dash of x is less than or equal to 0 for this interval, therefore the function given f of x is yes, what is it? Increasing or decreasing? Yes, by our given obtained conditions, since it is less than or equal to 0, therefore this function is decreasing function. This function is decreasing function in the given interval for x belonging to R. Got it? This function is decreasing function for x belonging to R. And if it is asked that it is strictly decreasing, when it will be strictly decreasing? If x is not equal to 1. Means at that time I have to subtract that set of singleton 1 from this set of real numbers. So I can mention here that one also, and f of x is strictly decreasing. Strictly decreasing. Here it is decreasing only, and now it is strictly decreasing if x belongs to R minus singleton 1. R minus singleton 1 means if x is equal to 1, this bracket becomes 0. Therefore, I will eliminate that value from my set, and then the remaining values of x now will give me strictly this f dash of x less than 0, and therefore the function will be strictly decreasing. Got it? Okay. This is how to find the function is either increasing or decreasing. Okay.